Number 32, what is an equivalent of 1 volt? Uh, 1 volt, ya. This is sebenarnya dari Joule's law, hukum Joule, ya. That um, energi, ya, volt, ya, potensial listrik, ya, V, ya, uh, V equals to work over charge. Yeah. So this is something with volt, yeah, uh, equals to energy in joule, charge in coulomb. Yeah. Volt equals joule over coulomb. Yeah. Or maka 1 volt itu equals to 1 joule coulomb minus 1. That's it. Jadi jawabannya adalah yang B. Ya. Joule per coulomb. This one. What about 34? The potential difference between X and Y is 20 volt. The time taken for charge carriers to move X and Y is 15 seconds. And at this time, the energy of charge carries 12 joule. What is current between X and Y? Okay. Okay. We use formula this one, yeah, to find charge first. This when I copy this formula, the V equals to W over Q. So we have 12 volt equals to 12 ya. Ini yang 12 ya. Dan ini adalah Q. So Q equals to 12 divided by 20, yeah, or 0.6 coulomb. And Q equals to IT, yeah. This Q equals to IT. Q 0.6, I, yeah, T is 15. Yeah. So I equals 0.6 divided 15. Okay, I counting first. 0.6 divided 15. 0.04. 0.04 ampere. Yeah. So the answer is on A, yeah. Okay, that's it. Hmm. 33. The terminal voltage of a battery is observed to fall when the battery supplies a current to an external resistor. What quantities are needed to calculate the fall in that voltage? The battery EMF and the internal resistance. What quantities are needed to calculate the volt in that voltage here? V I R. Oh no no I. Oh wait. Ini fall in voltage itu equals to EMF or E minus I R ya. Internal resistance. Mm, so it means uh, quantities we needed is about E and R. Yeah, yeah. Because I also we can find from uh, V over R. Yeah. So the quantities actually we needed is E and R, yeah, small r or internal resistance. Yeah. The battery EMF and its internal resistance. Okay, that's it. Yes. Continue number 35 in page 10. The diagram shows a battery of fixed resistor. Fixed resistor is in here, yeah. And ammeter and variable resistor. This is variable resistor. Connected in series. Yes, in series. A voltmeter is connected across the fixed resistor. Yeah. The value of the variable resistor is reduced, which correctly describes the change in reading of the ammeter and the voltmeter. Nah, ini reduce ya. Reduce itu diperkecil, maka yang terjadi itu pengurangan juga in volt, also in ampere. You see this reduce ya, pengurangan. It mean decreases here. It mean decrease resistance. Kalau decreases resistance ya, decreases in resistance, so The first one, ammeter, it will be increase. Yeah, uh, ammeter, it will be increase. But voltmeter, yeah, it will be we see from this formula, yeah, V equals I R, or I equals V divided by R. Let's see about this formula. I, because R is decreases, so I, it will be increases. Then V, because R decreases, so V, it will be decreases also. So the best answer is increases and decreases here. C. Ah, that's it. 36. Kirchhoff's two laws for electric circuit can be derived by using conservation laws. On which conservation law do Kirchhoff laws depend? Oh, yeah. This is when you remember, yeah. Uh, Kirchhoff first law, it's about uh, charge, yeah. And Kirchhoff's second law, it's about energy. Yeah. Depends by charge, yeah, and depends by energy, yeah. Second law. Yeah, number 37 is about parallel, yeah, parallel resistor. Yeah. That parallel is the formula 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. Yeah. We uh, we put this number into here that R combination is 3. Yeah. 3, yeah, in here, 1 over 12, 1 over 6, and 1 over R. So after we calculate this, yeah, into R equals to 12 ohm. Okay, continue to number 32. Oh, ini nggak bisa. Wait, ya. Oh, select. Uh, kita erase aja deh. Ya. Oh, hmm, ya. Continue number 32. Ya. The diagram shows four heaters and the current in each. Which heater has the greater power dissipate? Wow. When you remember P equals to I R square. Yeah. P equals to I, sorry, I square R. Yeah. I square R. Uh, Use this formula. Yeah. to find power with the greatest power dissipation. Which one? Yeah. Uh, when you see this, yeah, uh, by multiplication 8 and 2, 8 square, yeah, equals to 64. Yeah, 64 times 2 plus 64 times 2, 128, ya. 128 watt in here. Yeah. This one. Yeah. Second one, yeah, I square, yeah, 36 times 4. Uh, 36 times 4. 144. Yeah. Here is 144. Yeah. And the C1, yeah, 4 square is 16. 16 times 6. 16 times 6. 96. 96. Yeah. Last one. 2 square. Yeah. 4 times 8. 4 times 8 equals to 32. Yeah. What? Okay. So the greatest one is 144. Yeah. This one. Yeah. B answer. Yeah. B answer. Okay. That's it. 35. The diagram shows a junction in a circuit where three wires P, Q, and R, yeah, meet. Yeah. The current in P and Q is 1 and 3 ampere respectively in the direction shown. Yeah. How many columns of charge pass a given point R in 5 seconds? Or we combine about two questions. Yeah. It's about the first one is about Kirchhoff's law. Yeah. That's current on the R equals to, yeah. mm, Sorry. Ini I input, ya, 1 ampere plus I equals to 3 ampere. Yeah. So we get I is 3 minus 1, yeah, 2 ampere. This is I on the wire R. Yeah. Then if we find how many column charge, yeah, we find Q. Yeah. Q equals to I times T. Yeah. So Q equals to I is 2 ampere, 2 amperes times T is 5 seconds. Yeah. So Q equals to 10. Yeah. 10 columns. Yes, that's it. Actually, easy, yeah. Not so difficult. 34. The resistance of thermistor decreases significantly, its temperature increases. Yeah. The thermistor is keep in the air. The air is room temperature, which graph best represent the Y is the current I on the thermistor depend upon the potential difference P across it. Oh, uh, I will be near with the stable constant, yeah, but they never uh, when the temperature is, yeah, this equals to resistance decreases. Yeah. So it means V over R it's C. Yeah. C. Yeah. Answer is C. Why C? Yeah. Wait, I take first about the boundary. V over I. Yeah. Is likely continue up and start from zero. The first one is start from zero. Yeah. And when the temperature raise, yeah, it means resistor it will be decreases. Yeah, decreases it means yeah resistor it will on the constant relative constant. Yeah, so V and I it will be relative go to number V not likely not likely increases here. V relative constant, but E is continue rise. Ini akan membuat V itu ini kan gini, R itu adalah V over I, ya V over I. So ketika temperatur naik, resistance itu akan turun. Resistance akan turun. V over I itu cenderung akan naik seperti ini ya, karena V-nya karena ini dibagi X over I, ya, X over Y. Nah, kecuali kalau V di sini, I di sini, ini grafiknya seperti ini. Ya. Karena V-nya di bawah, I-nya di sumbu Y, so graphics like this one. Okay. See question the best answer. Okay, continue number 33. When a potential difference V is applied between the end of wire of diameter D and length L, the current in the wire is I. What is the current when a potential difference 2V is applied between the ends wire of the same material? The diameter is 2D and the length is 2L. Assume that temperature of the wire remains constant. what the currentnya? Okay. We find about R first. Yeah, R equals to L over uh, A, and then A depends by D. So it means if we put here R1 divided by R2, it means yeah L1 divided by L2 times uh, D, yeah, D2 divided by D1 but in square. Mm. Because inversely proportional with cross-sectional area. Yeah. So R1 divided by R2, L1 is L, L2 is 2L. So it means 1 over 2 times D2 over D1. D2 is 2D, D1 is D. So it means 2 square. 2 square is 4. Yeah. So R1 divided by R2 equals to uh, 2. Yeah. Okay. Uh, this is about R. Yeah. The second one is about V. Yeah. I put it is in here. V V equals to IR. Yeah. I equals to V over R. Yeah. So I let's say I2 divided by I1, yeah, equals to V2 divided by V1 times R1 divided by R2. So I2 divided by I1, yeah, equals to V2 is 2, V and V1 is V. So it means V2 over V1 is 2, yeah, times R1 over R2 is 2. Yeah. Uh, so 2 times 2 equals to 4. Yeah. Nah, kalian bisa lihat maka I2 itu adalah 2 kali I1. Ya. 4 kali I1. Jadi 4 I. Ya, that's it ya. Semoga kalian mengerti ini. Ya. This is about Ohm's law. This is about wire constant resistance. Yeah. So the answer is C. Yeah. That's it.